Okay. So if we're looking into this one then, so our first question is a ratio question. So we've got split 63 pounds at a ratio of 4:2. So there's a couple of ways of doing this. We could initially simplify our ratio here. So this would be the same ratio as a 2:1 ratio to make it a little bit simpler. But either way, it's going to end up with the same answer. So what we're going to do, we're going to collect all the pieces there. So that means there are 6 pieces in total. So we know that there are 6 individual pieces. So we'll have 63 then divided by 6, which gives us 10.5. So then we should hopefully from there end up, if we double that, then we'll have our 21 on the one side. And if we multiply that by 4, we'll have our 42 on the other. And like before, if we go down to a simpler ratio of a 2:1 ratio, it will be the same answer. Well, slightly different. It will be 10:5 and obviously to 21, but the ratio remains the same. It's still in proportion. So with question 2 then, unfortunately as well, it's quite difficult to write these as a fraction sometimes. So that is the fraction 3/7 of 28. So with this, if we were looking for a fraction, we'd take 28, we'd cut it into 7 pieces. So we've got our 28 divided by 7, and that's going to give us 4. And then we've got 3 lots of that. So we're going to have 4 times 3. So we should have ended up with an answer of 12 for that one there. So convert 3/5 to a percentage. So again, there's a couple of ways of doing this. If you're using your calculator, then you can just type in 3/5 or 3/5. And you can just type it in on there like that and press equals. And then when we press our little SD button there, it will just convert that to a decimal for us. So we should have 0.6. And then we know that decimals are out of 1, percentages are out of 100. So it's going to be 100 times bigger. So we should be looking at 60% there. So a washing machine was reduced by 20% and now costs £65. So what was the initial cost? So looking at this one, this is what we would call a reverse percentage problem. And if you actually look on the Google Classroom, I've updated that today. So there are some more resources on just this topic because I'm aware it does pop up a little bit more frequently than I thought. So looking at this then, it's an idea of, okay, so £65 is equal to our reduced percentage. So this is going to be equal to 80%. Because that's equal to 80%, all we're going to do then, our normal steps, we're going to find 1%. So we're going to take 65 and we're going to divide that by 80, and that will give us 1%. And then we can multiply that by 100, and that should give us a total of £81.25. So let me just clear that. No, it's not letting me. Okay, brilliant. So £81.25, that'll be our answer there then. Right, let me just try and... Okay, so... Okay, nice one, Stephen. Good to hear that. So moving on then. So our next one, we've got our rounding question here then. So we're going to round 4.5952 to 2 decimal places. So we are looking at our second decimal place here, which is a 9. Our 5 is going to impact that, and that is going to round it up. So it will become a 10. So our overall answer here, we should be looking at 4.6. So even though it's the 2 decimal places, you could have put 4.60. I'm sure you probably wouldn't lose the mark, but technically it is just 4.6. And then lastly, we've got a bit of a conversion question here. So we've got millimeters to meters. I thought I'd highlight this because they are doing this more, this kind of 2-step conversion, which they didn't used to do very often, but it does come up quite a lot now. So it's the idea of 150 millimeters. If we were to convert that straight away to centimeters, then that is going to be, obviously, with there being 10 millimeters in a centimeter, that's going to give us 150 centimeters there. When my mouse starts working, there we go. So 150 centimeters, and then there are 100 centimeters in a meter. So if we divide that by a further 100, we should end up with 1.5 meters. So most people have done pretty well with all of that. There doesn't seem to be any major kind of issues. If there are a couple of questions that you've missed, please don't worry. It's a simple case of, you know, it's a lot of content that we're covering, and you do have social lives, families, work, other things that are a bit more important than maths. So don't worry about it. Okay, so so today the aim is we're going to look at our session 6, which is regarding area, perimeter, volume, and surface area. So the main topics here then, we're going to look at what area, perimeter, volume, and surface area are. We're going to learn to calculate the area and perimeter of simple shapes, and I'm sure most people will be quite all right with this. There's quite a lot of examples on here, but once I've kind of got the feeling that everyone's quite okay, I'm going to skip through them for time purposes, so we can spend more time on the bits we need to. We then need to look at calculating the area and circumference of circles. This is appropriate for level 1 and level 2. So all of this content here is appropriate for level 1 and level 2, depending on what exam you're doing. And again, we'll look at the two formulas there, and unfortunately with this, it is a case of memorizing them and knowing what they are. We're then going to do some work with compound shapes, and again, this is relevant for level 1 and level 2. So a compound shape is kind of not a regular shape, so to say. It's almost two shapes stuck together, and how we can solve those problems. We're then going to look at calculating volume and surface area. And then we're going to have a review and assessment, which is obviously all of the resources that are now up on the Google Classroom. So there's a lot of different resources on there, a lot of kind of questions with the answers there, a fair few different PowerPoints, because I'm aware that having different explanations can be really useful. And again, that will be the assessment that we'll be looking at later on. There's not as many functional problems in this kind of session. It's more important that we just know the theory behind it, and then we can apply that in the worded problems when you see them in the assessment. Okay, so very quickly then, as an overall recap. So looking at here then, so we have our first shape here. So it's the idea that the perimeter is the outside of a shape. This applies for circles as well, although they call it the circumference around the outside of the circle. It is still technically a perimeter, it's around the outside. I believe it's Greek, but peri always relates to outside. So NHS-wise, if you're ever looking at a heart or anything like that, you have a pericardium, which is the outside of the heart. It's the bag outside the heart. So if you ever see the word peri, it normally relates to the outside of something. I always like remember this by, I think of like a perimeter fence. It's always a fence around the outside. So anytime we see perimeter, it's the outside of a shape that we're working out. And we'll look at the units for this in a second. So when we are looking at area, then it is the inside of the shape. So everything on the inside of the perimeter is going to be the area. When we go a step further and we look at volume, so volume is the space inside a 3D shape. And our last one is surface area, and this is the outside of a 3D shape. We will look more into these, so don't worry about them. We're going to look at each one of these individually, so don't worry, this is a very brief kind of overview. In regards to units then, if we're looking at, say, in centimeters, so the perimeter of something, we're just looking at a straight line, it's just going to be centimeters there, and that's going to be it. When we're looking at the inside of a shape, or when we're looking at an area, it is always centimeters squared. We'll look at why this is in a second, but it's always centimeters squared, meters squared, kilometers squared, inches squared, foot squared, anything. It's always a squared unit. And then when we go to looking at volume, it's always going to be a cubed unit. So essentially, that's going to be to the power of 3. So centimeters cubed, meters cubed, anything like this. The thing that helps me remember it is just you're looking at the amount of dimensions. If you're looking at just a straight line, really it only has one dimension, so it's just centimeters. Centimeters squared, we've got 2 dimensions. We've got height and we've got width. So that's why it's centimeters squared, centimeters to the power 2. When it's volume, we're looking at centimeters cubed because we have height, width, and depth now. When we're looking at surface area, though, surface area is, because it's an area over a surface, that will be in centimeters squared or meters squared. So we can normally tell what we're dealing with by looking at the units as well. So if they give you a question and it mentions centimeters squared in there, then we know we're going to be dealing with an area. If it says centimeters cubed, we know we're dealing with a volume. So it does actually give us a bit of a hint as to what kind of question we're dealing with. So if we go into our first example then, so I'm hoping everyone's okay with this. So if we're looking at the perimeter of this rectangle, it is just counting all the way around the outside. So let's pretend that these are centimeters squared, these little blocks here. So it's a simple case of saying, okay, well, it's 5 along, 3 high, 5 along and 3 down. So our total is going to be 16 centimeters. If we then have a look at what the area of this rectangle is going to be, we could, in this case, go through and we could just count all of the squares in there. So we know there's 5 on the top row, there's another 5 on the second row, and there's 5 on the bottom row. So in this situation, we've got 15 centimeters squared. The reason why, when we look at this, and most of the time, most people know this by, when you calculate an area, you just multiply the bottom and you multiply the side. The reason that works is because it's 5 centimeters long and it's 3 stacks of them high. So it's 5, add 5, add 5, but we know multiplication is just constant addition. So that's why we multiply the two numbers together. So there's a simpler version of it there for you. Again, always really important to take note of the units. This has popped up a lot, and I have purposely put this into a lot of the problems where I've changed the units. So one length might be in meters and another might be in centimeters. The reason this has happened is because they keep putting this in the exam questions, and it's absolutely brilliant for us because it is such an easy mark to gain. All we have to do is a simple conversion at the beginning and we get an extra mark. So it's really nice that they're actually doing that. So if we think about it then, we can write 3 times 3 as 3 squared. We're quite happy with that as an idea, like 3 times 3 is 3 squared, or like in the same way, if it was 5 times 5, it could be 5 squared. That works the same as with units. So that's why, because we've got centimeters along here and we're multiplying by centimeters, that's why it's centimeters squared. In the same way, if we're dealing with a volume, it's centimeters times centimeters times centimeters. So it'll be centimeters cubed to the power 3. So that's why the units end up changing as well. So always look at the units in the question. Exams are constantly using different units there. And it's a brilliant way, as I was saying, for us to get our extra marks just by simply multiplying by 10, 100 or 1,000. So it's a brilliant thing to have in there. So as a quick example then, I'll just talk through this one more and then we'll have a bit of a look at this without the kind of like the gridded guidelines on there. But I hope you're all quite happy. If we are looking at the perimeter here, then it's a case of just literally counting the squares around the shape, or if they've just given us a measurement, we're just adding them together. So we've got 6 along the bottom there and it's 4 high, so it's going to be 6, add 6, add 4, add 4, which is going to give us a total of 20 for our perimeter. When we're looking at the area, again with this, because it's got all the little squares on there, we could just count every single square, or we can do it quicker. We know there's 6 along the bottom and it's 4 high, so it's going to be 6 times 4 or 4 times 6, the same thing. And that's going to give us our area of 24 centimeters squared there. And again, it's centimeters squared because there are 24 of these little centimeter squares in there. So nice and straightforward. So the area of a rectangle then, I think we're all quite happy with calculating this. It's the idea of it's the length times the width, or by the height. One times the other. There's a fancy way of writing it, which is like this, which looks a bit more mathematical and a bit more confusing, but we know exactly what we're dealing with. The area is the length times the width. So if we were to look at this rectangle here, I'm hoping everyone will be quite happy, even though we haven't got our little guidelines, our little squares, we know that the area of this is going to be it's 8 centimeters long, 5 centimeters high. In total, we're going to have 8 times 5. And it doesn't even give us the answer, but the answer there is going to be 40 centimeters squared. So don't worry, you will get to try a couple of these in a second. So getting on to another area. So the other main area that we need to know is the area of a triangle. And this hopefully will help kind of explain how this concept works. The idea of calculating an area of a triangle is if you take the area of any four-sided shape, you can potentially cut it in half and make a triangle. So this will work with any four-sided shape. So, you know, even if the square's a little bit wonky, like this terrible drawing I'm doing, okay, we know that that square, we can cut it like this into 2 triangles. This kind of concept also relates to the idea of how many degrees are in a shape. So if we know that a square is made up of, or a rectangle is made up of 4 right angles, each right angle is 90 degrees. So therefore the total sum of our square is going to be 360 degrees. So therefore when we cut that in half and we make a triangle, our triangle is only going to have 180 degrees. And again, it's a nice thing because it works with even bigger shapes as well. I'm getting a little bit off topic, but it's worth it. So the idea of this, so this is a 5-sided shape, so a pentagon. If I start from one vertex and I just draw across here, I can actually cut this shape into 3 different triangles. If I know that there's 180 degrees in one triangle, if I've got 3 lots of 180, I've got 540 degrees. So that means that every pentagon or 5-sided shape will total 540 degrees. We will review this, so please don't worry about it. But that's the idea. So any square, we just work out the area of a square, which we know is our height times our base, and then we cut it in half. And again, it doesn't matter what triangle we're dealing with either. So even if we have a strange looking triangle like this, so this would be a scalene triangle, as long as we have this vertical height here, and we have the length of the base, we can still work out the area of a rectangle around it, like this, and then half it. So that's why it will always work. So moving on then, so the area of a triangle is just the height times the base, and then we divide it by 2. So we work out the area of a square or the area of a rectangle, and we cut it in half. So those are the 2 main ones that we need to know. And again, for the perimeter here, we could just add all 3 of these sides together, and that will give us our area. You could also write it like this. So we know that dividing by 2 is the same as multiplying by a half. Not really relevant. So again, like with this triangle here, if I were to just talk through it. So what we'd do first of all, we'd find the area of a rectangle around it, which would come out here. So that would be 5 times 8, which is going to give us a total area. So we've got our 5 times 8. So that gives us an area of this rectangle, which would be 40 centimeters. And again, in this case, it's going to be 40 centimeters squared. And then we know that we need to half that value. So again, I always prefer to write it as a fraction because I'm aware that a fraction is a sum. So if we half that value, we're going to end up with an area for this triangle of 20 centimeters squared. So I'm hoping that's okay with everyone. And what we'll do is we should be moving on to a couple of kind of practice questions now. So we can actually have a bit of a look at it. Oh, there you go. It's done all the working out for me. So a half times 8 times 5, that's one way of doing it. Or like how I've done it there, 8 times 5 divided by 2. It's a lot easier to remember that way. And luckily we got the same answer. Okay, so here are a couple of examples for you then. So if we look at this first one then, so if you can try and work out the area and the perimeter of this shape, and then just let me know when you've done that. Either pop it into the chat or obviously message it to me, whatever you want to do, or just write in, I've worked it out. And then we'll move forward from there. So if you can try and everyone work out the area of this and the perimeter, please. Yeah, similar, absolutely perfect. Karina, spot on as well. Yeah, Natalie, no worries there. Yeah, Rowan, just be careful in regards to what, yes, and what what wording we're using. So just remember, area is the inside, and perimeter is around the outside. So it'll be you've got the right answer, just the wrong word in front of them. And obviously, our units. I know it's hard to type it because we can't do a superscript, but the units will be centimeters squared when we're talking about the area. Yeah, everyone seems quite happy with that. That's brilliant. So I'll just put up the answers here very quickly then, but I think everyone got that one right. So we've got the area is going to be 8 times 6. It's 8 centimeters long and it's 6 centimeters high. Yeah, James, spot on. So 8 centimeters long, 6 centimeters high. Multiplying them together, that's going to give us an area of 48 centimeters squared, because again, we're multiplying centimeters by centimeters, so it's a squared unit. And then our perimeter there is going to be 8 add 6 add 8 add 6, which is going to be 28. So spot on. So if you want to have a go at working out the area of this triangle then. So again, I'm liking it. It's saying about the area of the triangle. It's important to remember that it is the vertical height. It's always the vertical height and the base that we're going to be using. So there's actually a number in there that we don't need. The fact that it's a right angled triangle there isn't necessarily, that doesn't help us at all either. It's not really needed. I better work out as well, actually. So again, just remember, put that there as a bit of a hint as well. Yeah, James, absolutely spot on, buddy. Becky, spot on. Yeah, Natalie, nice one. Yeah, Rowan, I'm not quite sure with that one. It's gone a little bit. I'd be interested to see how we've come up with that as well. In all fairness, it might be just a common kind of just like a little mistype or something. I think. Oh, cool. Someone's so worked out the perimeter as well. So nice one, Simonetta. Okay, brilliant. So if I start going through this, so the idea when we're calculating this, so we're just going to work out the area of the square first of all. So our area of the square is going to be our 5 times 12, and that will give us a total of 60. And then once we've got our 60, we're going to cut that in half, and that's going to give us an area of 30 centimeters squared there. So again, if you do want to practice this a bit more, there are an absolute ton of resources on the Google Classroom now. All of them have the answers with them as well. So you should be absolutely fine there. And again, just remember, one thing I would suggest, I mean, because it's written a bit poorly here, sometimes just do remember the BIDMAS, the idea of it. So sometimes, you know, on certain calculators, you want to work out the area of the rectangle first and then half it, just in case. Yeah, it's a really common problem with these as well. Sometimes it's just simply forgetting to half it as well. So do be careful with that. Okay, brilliant. So I feel like we're actually doing quite well with these. So what I'm going to do, I'm going to skip over this one because there's a couple of other ones which have a bit more thought involved with them. So these are the exact same. So again, work out the area of this triangle. We know it's going to be the same concept, 7 times 10 and then half it. The same with this kind of rectangle. So so what I'm going to do, I'm just going to move through these ones so that you can then look at them like a bit more in depth at a later point. So what I thought instead, just to make it a little bit easier, so we'll look at a few of these questions, because again, I've put some things in there regarding the units, so do keep an eye on the units. So if anyone, again, just type in your answer A, B, C, or D. So we've got the idea of what is the area of this square going to be. I've just got loads of showing up on my screen now. It's brilliant. So do remember, it's going to be, in this case, it's going to be 81 there. And again, there's a couple of little things, and they do kind of do this quite nicely for us. Sometimes it's easy to look at and work out the perimeter, which is why I put this in here as a kind of try and catch you out. It's going to be this one, but again, because we're dealing with an area, we know it definitely can't be this one because the units aren't correct. So spot on. So with this one then, so what is the area of this rectangle? And again, I will give you one more hint with this. Do pay attention to the units. So our options are as follows. So I'm hoping that should give you a bit of a hint as to how to convert your units in this case as well. Oh, brilliant. No one's getting caught out with this one, are they? Yeah, Karina, spot on. Brilliant. So with this one, again, it's just the idea, because this does pop up a lot of the time. Everyone's absolutely spot on with this one. It is just this idea of being careful, just looking at the units first, because I've seen them do it a few times. They've done it where they've given one measurement in meters, one in millimeters, and one in centimeters. But what can really help us is looking at the answer further along and seeing if it says, a tin of paint will cover this many meters squared, then we know that we're going to be wanting to convert everything into meters. But yeah, everyone's absolutely spot on with that one. It is going to be 32 centimeters squared. So this one, we're going to go with the perimeter of this square. And the nice thing is, questions like this will pop up, just simply even at this kind of level, where it's just a case of this would probably, it would definitely be worth 2 marks, potentially 3, because there's a conversion first, and then there's demonstrating a knowledge of what the actual perimeter is. So, so just remember, we are dealing with the perimeter here, so we're going around the outside of this shape. Yeah, brilliant. Well, everyone seems all right with that then. Right, if it's okay with everyone, then I think what we're going to do at this point is going to move a bit further forward. And there are a few more of these, but if you want to review them, then obviously look at the PowerPoint in the on the Google Classroom, and it will obviously help you out with that. So with this, so the perimeter on this shape will be obviously 4 centimeters, add 4, add 4, add 4. So we've got potentially 4 times 9. And then with the area, it would be 9 times 9. So it's again that idea of if it's tricky, draw a picky. I always get the idea of I can literally just draw the markings on there. I could draw 9 little markings along there, 9 markings up here, and I can just count all the squares if I really wanted to. Okay, so I'm just going to skip over these ones quickly because we do need to get moving on to some of the other content. But there are some other kind of other questions on there. So there's an incredibly bad maths joke for you. Obviously, who built the round table? It was circumference. Sorry. So moving on then. So with circles, there are only two main things that we need to know regarding circles. We need to know how to calculate the area of a circle, and we need to know how to calculate the circumference. So based on that, there's just a little bits of terminology that we need to know. And I wanted to talk about pi a little bit as well, because when you actually understand what pi is, it does really, really help, because a lot of people, they just go, oh, pi, it's something to do with circles, it's 3.14. It's actually a pretty amazing number, and hopefully I can prove that. So first one, so we need some key terms then. So to conquer pi, we need to know the basic terminology. So the main things that we've got, and so we've got circumference. So that is around the outside of the circle. It is the perimeter of the circle, but it's called a circumference, and that is the distance around the circle. We then have what we call a radius. So that goes from the center of the circle to the edge of the circle. And that is going to be the same at any point around the circle, because a circle is circular. Obviously, from that middle point to the edge, no matter where that is or where you draw it, it's always going to be equidistant. It's always going to be the same distance away. So the radius is a line that goes from the center of the circle to the circumference. So from the center to the edge. And then the only other one that we need after that is our diameter. And the diameter is a line which touches both sides of the circumference and passes through the center. So I always remember the difference between these. I mean, with these, you do just need to kind of remember the names. I always remember diameter. Di is very, very common in regards to meaning two. So the diameter is simply 2 radius. It's from the center to the edge and from the center to the edge. So if we have 2 radius, it's the exact same as a diameter. It's quite an important thing to remember when we start looking at some of the further questions. And then that question isn't really important for anyone that is interested. That's Aerosmith. I've taken this slide from when I was teaching in a school, and they all had no idea about good music. So I was trying to kind of, a bit of a hidden curriculum, trying to help them out learn some decent tunes as well. But so hopefully everyone's okay with these kind of terminologies then. So these are the only terminologies we need to use. There are a lot of other ones. So we have things like a sector, a section, an arc, all of these things. You don't need to know any of them. I'm getting a lot of support from the Aerosmith fans as well. Thank you guys. We're still rocking and rolling. So moving on from here then. So we know our key terminology now then, and we're aware that Aerosmith are absolutely awesome. So thinking about a circle then, and this is what's going to link in with pi then. So the idea of a circle, so we've got all these different circles, all these different sizes. What people found out is that if you take a circle and say we cut it and then we roll it out, so if we straighten that out, so that is the circumference. So we've got the circumferences around the outside of the circle. If we take that circumference and we stretch it out and we measure it, what that's going to actually happen, if we have the circumference of a circle and we divide it by the diameter, you always get the same number, which is this number here. It looks incredibly horrible and ridiculous. That is pi. Pi goes on for infinity, and we normally shorten it, and most people be quite happy with looking at pi as 3.14. So there are competitions with who can remember the most digits of pi. I think there's a Chinese chap at the minute who I think can remember it to 10,000 places. I don't know why, I've got better things to do, to be honest, but it's a simple case. This general ratio, though, is really important, because I never learned this in school. They never told me that. They just went pi is 3.14, and that's it. But what it is anytime you have the circumference if you divide the circumference by the diameter, you will always get pi every single time. It's pretty insane, really. But this works really well because it means we can put this into a bit of a formula, and we can actually use that to kind of help us understand how we can calculate missing values in a circle. So the formula for it, and again, it looks a bit fancy when we see it, but it's, since we know that pi is the circumference divided by the diameter, we can put it into a formula triangle. And we're going to be looking at more of these next week when we look at speed and we look at mass. But in general, it looks like this. So if you haven't ever seen one of these triangles before, please don't worry. They're absolutely amazing. They will save you such a load of work and such a headache as well. So the idea is, with this formula triangle, because we know that the circumference divided by the diameter is pi, if we can look at this triangle, then we can actually work out any of those figures. So if I cover up circumference, so you cover up the thing that you want to know, I know that if I wanted to work out the circumference, I would do pi times diameter. And that will tell me the circumference. If I wanted to work out the value of pi, which we all know and is common knowledge, it tells you it on the front of the exam paper as well. And we've got the button on our calculator to tell us as well. But if we did want to work out pi, for some reason we wanted to see how circular something was, we could do circumference over diameter. So circumference divided by diameter will give us pi. And then the same time over here, if I cover up diameter, so if I had a question and I was given the circumference of a circle and it asked me to work out the diameter, I can now look at that and go, well, that's circumference over pi. So circumference divided by pi, and that will give me the diameter. So this triangle itself, you don't really need to remember. The main thing is that you can remember that pi times diameter is circumference. That's the best way of remembering it. But it just helps having a bit of extra knowledge and knowing what pi is, because a lot of the times with circle problems, you'll look at them and then you feel a little bit out of depth because you kind of almost feel like they've given you too little information. So again, using this, we can work out any components that are missing. So we can see up there, so there's another formula for this as well. Both of these are the exact same, but you might, some people, I remember it from school, I was always told the circumference is 2 pi r. Whereas I've just told you that the circumference is pi times diameter. The reason being, these are both the exact same. If I've got 2 lots of a radius, then I've got a diameter. You remember obviously the radius going across the circle. If I've got 2 lots of them, that's the exact same as the diameter. So either of these will give you the circumference. So you can type into your calculator 2 times pi times radius, and that will give you the circumference. Or I just find it a bit easier to remember, just pi times diameter. And again, if we have a circle question where it's asking us to find the circumference and it's only given us a radius, we know that all we have to do is double that radius, and then we've got our diameter and we can work out our circumference from there. But it's just some people might remember that one from school, so I thought I'd put that up as well. So I've got a couple of questions for you then. So working out the circumference, then we know what we're dealing with. It is pi times diameter. And here's just a quick example of it. So if we've got a diameter here of 10 centimeters, to work that out, we're just simply going to do pi times 10. You can use the pi button on your calculator, or again, they will say on the front of the exam paper what they want it valued to. So it will normally just be 3.14. So it's normally to 2 decimal places. What you might find though, and I'll point it out now, if you try and type this in on your calculator, so if I type in, oh, I need to be able to see myself too. It's run away. So if I type this in on my calculator, so if I type in pi times 10 and I press equals, my calculator will say 10 pi. And again, this is just a case of pressing that little magic SD button again, and it will convert it into a decimal for me. So it will then tell me that the answer is 31.41592654. And again, the great thing... Yep.
Sorry, Trish. Where's the pi button? I can't see it. I've got the same.
Oh, okay. It's can you see there's a button that says times 10 and x? Should be on the bottom row. So this one down here.
Oh yeah, sorry.
So it's that button.
Yeah.
If you look above it though, that you can see the pi symbol in yellow.
Yeah.
So that just means you have to press shift first.
Yeah.
So you've got the shift button there. So we're going to press shift there. And then when you press that, it will type in a little pi symbol for you.
Oh, lovely. Thank you.
All right, no problem. And again, you can do it, using the pi on your calculator, or you can type in 3.14 if you want to remember that.
Yeah, there is a little P Greek yellow on the top of the button.
There's a what? Little yellow symbol on it?
Yeah, on the top.
Yeah, it says these calculators can look a bit confusing, can't they? But the more we get to know them, obviously, the better we're getting along with them. So, but so that's the idea as to how we would calculate these then. So is everyone okay finding the pi button now? Are we okay with that? Yeah, spot on. So
can you show again on a calculator how to do it?
Yeah, that's okay. So if you've got the same kind of calculator,
yeah.
Again, we're gonna find the shift button, which is up here. Yeah. So we're gonna press shift, and then when you press that times 10x button down here, the one with the little pi symbol above it, when you press that, it should then come up with a pi symbol.
Yeah.
Yeah. Yes. So that's the pi there. So then for this question here, we then just, once we've typed that in, we just do multiplied by 10. So we just type in times 10 afterwards. And then when you press equals, it will give you the answer. It will just say 10 pi. But then when you press that SD button, it will convert it for you. Brilliant. Nice one. Okay, so if I put up a few examples for you guys then, and again, I've put a bit here because they do this quite commonly. So it says, give your answer to 1 decimal place. Again, this is a brilliant thing for us because it's, again, a simplification question. So you'll get an extra mark for just simplifying your answer down. So it's a really good way to get some extra marks. So I'll put a few there for you. What I'll do is I'll leave these up for a couple of minutes, probably about 3 or 4 minutes. Have a go at a few of these. I'll talk through the first one, but yeah, have a go at a couple of these, and then once we've had a little bit of a look, I'll put the answers up for you so you can check them yourself. And then while you're working through them, I'll just talk through the first one. So the first one is saying we want to know the circumference of this circle, and our diameter is 8 centimeters. So we know that this line here is our diameter, and that's going to be 8 centimeters. So we know that in this case, our sum is going to be 8 multiplied by pi, or multiplied by 3.14 if you've got an old school calculator. And then whatever that gives us, so if I type that into 8 times pi, so that's giving me an answer of 25.13274,123. And then if we're giving that answer to 1 decimal place, so it would be 25.132, etc. If I only want my answer to 1 decimal place, which is there, I'm going to just draw my line in here. I'm going to cut this bit off, and because that's a 3, it's not going to round it up. So that will just be 25.1 for your answer there for number 1. Again, similarly, so that will be the same for all of these. When you're looking at the radius, it's just remembering what the radius is in relation to a circle. So with the first one here, we've got a radius in this case of 6 centimeters. And that means that the diameter is going to be 2 of these radius. So I'm hoping we can see there that our diameter is therefore going to be 12. So for the first question down here, that will be 12 multiplied by pi. So I'll leave those examples up for a second and just give you guys a minute or so to have a look through them.
Sorry, Tom. Can you just run through the radius again? I didn't quite catch that.
Yeah, of course, no problem. So with the radius of a circle, so looking back at our key terminologies then, so there's a really bad circle. So the radius goes from the center to the edge.
Yeah.
So if we know that in this case is 6 centimeters, obviously using our formula, we normally just do our diameter.
Oh, it's just. Oh, sorry. Am I being silly?
No, that's all right. What were you going to say? Is it?
What is the question asking there? It wants us to find out the diameter then.
So in this case here, so in all of these questions here,
Yeah.
so it's giving us the radius of the circle, but it wants to know the circumference.
Oh, okay.
So it's just we have to kind of look in a little bit deeper. So we know how to work this out if we've got a diameter, but it hasn't given us that yet. It's given us a radius.
Okay.
So if we know that the radius is 6, then what's our diameter going to be there?
12. So then we're using the 12 times.
Exactly.
Yeah, I get it.
So
Lovely.
it's really nice. It's testing a little bit of underpinning knowledge, but the great thing about it is if that was a question, it'd be worth 3 marks minimum, because it's 1 mark for working out the diameter, 1 for calculating the circumference, and then 1 for actually simplifying it to 1 decimal place.
Oh, right. Okay.
So it's a really, really nice question sometimes. So
okay. Lovely. Thank you.
yeah, no worries. Karina, I'll just check that one for you. It's close. It's so for that one, it's just looking at when you're simplifying and when you're rounding your answer off. Yeah, there you go.
I think I wasn't sure. Sorry.
Yeah, no, that's okay. It's still a bit strange, like kind of knowing when to round and when not to round kind of thing. But yeah, we're on it. So I'll give you guys another minute or so on this, and then we'll get moving through. Brilliant stuff. So getting quite a few answers coming in now then. I am just a little bit cautious of time. So what I'm going to do is just kind of load up some of the answers now, but just know that these are all still on here. So if you do want to practice them, there's a lot of the worksheets to obviously use. It's just we need to try and get through the content more than anything. So if I just quickly clear that away for you, and then looking at our answers here then. So hopefully you can have a look at them. You can mark some of your own ones. Hopefully everyone's done okay with that. If I just check the chat, there's a lot of 64. Yeah, so a lot of them we've rounded them just to like the whole numbers, haven't we? But
would we get marked down if we didn't round them?
In this case, because it's said to give your answer to 1 decimal place, you wouldn't actually get that mark for it. You'd still get the 1 mark for getting the answer, but you wouldn't get the mark for giving it in the certain form.
Right. Okay.
So again, I feel really bad putting stuff like that on there, but I'm just trying to get you prepared for just how silly the exam is sometimes. So, but hopefully everyone's okay with that. Is everyone all right if I?
The last one, the E, it
And
doesn't come out the same. I don't know why.
E, what is it? This E here or this one?
Yeah, the radius. I did 100.
Oh, so down here, this one here.
The last one, E. Yeah.
Yeah, so we've got a radius of 50, which means the total will be 100. So 100
yeah.
times pi.
I did pi equal. I see. And it's coming out 314.1.
Yeah, I'm getting the same for that one. So I think that might actually be a misprint on there. So I think you've beaten the PowerPoint.
Okay. Because I did twice and you know, and it's 10, 10, 10, and the pi is 3.14, and obviously related to 1 to 10, it must be 3.14 anyway, because
Yeah,
it's not an equal number. It's yeah, I think.
I really don't understand the number 2. So after do the time is 2, I don't know what to do.
oh, okay. So basically, all that's happened is once you've multiplied it by 2, so we're taking all these and essentially we're timesing them by 2, yeah. And what that's then given us is the diameter. So in this case, for the top one, we then know that we've got 12, and that's the diameter. The only reason we're working that out is because we need to know the diameter to work out the circumference.
So when I get the diameter, I do exactly the same I did on the question number 1.
Spot on, yeah. So once you've got the diameter, you will just multiply it by pi, and that will give you the answer. So like here as well, so if we had this 18 here, and we're going to double that, which will give us our 36. So we know that the diameter is going to be 36, and that's diameter. And then we're just going to multiply that by pi, and that will give us the answer there.
Thank you.
No worries. Okay, so I'm going to have to start moving on then. But again, all of this is there for you guys to look back at if you need to. So the next formula that we have then, and this is the only other formula we need for circles, is in regards to finding the area. So this is the formula for finding the area. And we just really need to remember it. So it is area is equal to pi r squared. So I used to find it a little bit difficult. I used to get a bit confused between how to know what formula to do. So I remembered both of the formulas, and then I'd look at them both and go, well, how do I know what one's what? One thing that helped me is I know that this one here is going to be the circumference, and this one is going to be the area. I know that this one's going to be the area because I just look at the units. I know that every time we're dealing with an area, our units are squared. We've got square centimeters, meters squared, things like that. So that means that this one here is going to be our idea for calculating the area. That is just one formula that you'll need to remember. It doesn't come up all the time. Sometimes they will give that to you as well, but they don't have to. So it's worth remembering. Essentially, how you type this in on the calculator as well, if you do have an older calculator, because it's r squared, you can just type this in as pi, and that will be multiplied by radius, multiplied by radius. So the reason they've written it like this is because although it looks more complicated, it's actually simpler. If you put like a multiplication sign in there, it would look like it's pi rxr, and then you might go, what the hell is an x? I don't even know what that is. So in most of like the European countries, it tends to be that you'll find these dots in the middle, and they will signify multiplication when you're looking at kind of algebraic terms. With this, though, it's just mathematicians being lazy. Instead of writing pi times r, you just write pi r squared. It's a shorter way of doing it. So that's our formula then. And here's it at work. So we know here that the radius here is 7 centimeters. So to work this out, we're going to do pi times 7 squared. And that's going to give us our answer there. So we've got pi times 7 squared. So 7 squared is 49. So then pi times 49 gives us this, and then we can simplify it. So again, it might just be worth just using this a couple of times just to get the hang of it and get it feeling a bit more natural. So here's a couple of questions then. Regarding these later questions, I will talk about them in a minute because they do pop up relatively frequently, but I'll explain them in context in a minute. So if you just wanted to have a bit of a look at maybe just the first, so the formula for finding these is pi squared, explain what this is. So yeah, so ignore question 1. We're just looking at question 2. So we can ignore all of that one. Don't want him. So yeah, we're just looking at question 2. So it's find the area of these. So with each one, so if I'm looking at this first one here, I'm going to use my formula, which is pi r squared. So that's going to be pi times the radius squared. So pi times 2 squared. 2 squared is 4. So that's just going to be pi times 4. And that will give us our area. And then it's just remembering to make sure you put your units in the right area as well. So because it's an area, it won't be centimeters, it will be centimeters squared in that case. So I'm just going to leave that up for you. So if you guys want to have a go at the first kind of 2 or 3 of these, again, even if it's 2.2 squared, you can type it all into your calculator in one go.
Tom, is the first one then 12.5?
Is
no,
the first one
12.6.
12.6.
I got the same.
Let me have a quick look. So it would be, so shift pi, and that's going to be times 2 times 2. So I'm getting 12.56637, etc. So when we round that, you should be getting 12.6 for that. Is that all right?
Oh, okay. Yeah, perfect.
Yeah.
Thank you.
Spot on. No worries. So again, it is the idea with things like this. Unfortunately, I can explain what it is and how it works, but this is one of the areas of maths where unfortunately it is a case of kind of practice makes permanent. So I would recommend after this session having a bit of a look on the Google Classroom and just going through a few of these questions just to kind of get it stuck in your head, and maybe just writing the formula down a couple of times, just so again it sticks with you. Lovely. So getting some answers in there then, brilliant. So yeah, Karina, they're all looking really good. Yeah, Steve, same for you, mate. They're looking decent. It's again just with these, it'd be rounding it to 1 decimal place. Obviously, it's what the question's saying. So just kind of paying attention to that kind of little bit of detail. But normally, obviously, if it was worded in a functional skills exam, it would be very clear. Cool. So we've got some good answers coming in then. So I'm just going to very quickly, I'm going to load up some of the answers then. Because again, we do need to obviously get moving on a little bit. So these are the ones that we were looking at initially. So just these first 4. So I'll move that over there. So the first one, so these were the straightforward ones then. So we should have 12.6, 78.5, 15.2, and 308.1. If you're getting anything really, really different, it might just be worth kind of just double checking that everything's getting kind of typed in properly on the calculator. So like for question 2, it is a case, it will be 5 times 5 times pi. You can write it in any way. You could do 5 times pi times 5. You're going to get the same answer. Everything's being multiplied together. I'm just going to double check all of these as well, because I'm a little bit worried that they might be, they could potentially be incorrect as we saw earlier. So so far they're all spot on. And then for D, it's 11 times 11 times pi. Yeah, so they're all absolutely spot on then. So all I'd say, so looking further then, I'll just talk through these ones very, very quickly. So what we do find sometimes is like here, so these next questions, they are giving you the diameter and then asking you to obviously calculate the area. So from the diameter, we know that the radius is going to be half of that. So we can divide it by 2 to give us our radius. And then we just put that radius into our formula. So pi, so like with the first one there, if our diameter is 10, our radius is therefore, if our diameter is 20, our radius will be 10. And then we can just use that. So it'd be pi times 10 times 10. You'd end up with 100 pi. One thing that does come up quite a lot, which I'll just draw a bit of attention to, is these ideas here. So the idea of like a semicircle or a quarter circle sometimes on a shape. To work these out, all we do is very similar to when we're dealing with a triangle. You just work out the entirety of the circle. And then you just divide your answer by 2 because it's half a circle. And again, same here. If we were looking for a quarter of a circle, we do the exact same sum, exact same maths. We get the area for the full circle, and then we just divide it by 4. And that will give us the answer there. So I hope that's okay for everyone. And again, if you do want to look at these, the questions will be there with the answers for you. So if we move forward a little bit further then.
Sorry to keep interrupting you, Tom.
No, that's okay, don't worry.
When we sit this exam, will we be allowed to use our calculators through this? Because at the moment I'm using the calculator to work out what a squared is, because I don't know. But how do you work out what squared is? Is it just times by itself?
Yeah. No, that's a really, really good question. So yeah, one thing that does pop up a bit, and again, it's one thing I've noticed from the most recent exams, is having a bit more of a knowledge on indices, which is your squared and squared roots. So very quickly then, so yeah, so all of these questions you would be allowed to use a calculator for. In regards to finding square numbers, it is just worth probably knowing your square numbers up to 100 would probably be the best idea. So knowing what a square number is spot on. So we know to say 5 squared is going to be 25 because it's 5 times 5. 6 squared is going to be 36 because it's 6 times 6. And just being able to spot these numbers, because what is coming up at the minute is these kind of things. So let's say we've got the square root of 36, and then we're going to add 9 times 2. So there have been some strange sums like this popping up, which is very much pure maths, but for some reason they're making their way in. It's just the idea of remembering that if you've got a calculator, this is fine, but this is popping up on non-calculator as well, and it's been throwing some people. So we know that everything in maths has an opposite. So the opposite of addition is subtraction. The opposite of multiplying is dividing. So the opposite of squaring a number is square rooting a number. And they'll only ever give you this with a square number itself. So it will always end up as a whole number. So that's nice. But it's the idea of, like, to say if I've got 6 down here, I know that if I square 6, so if I do 6 times 6, I'm going to square it. I'm going to end up with 36.
Yeah.
So 6 squared is 36. Therefore, if I square root 36, it will be 6.
Okay.
There's no real quick way of working it out either. It is just a case of looking at it and going, okay, so say if it was, let's say 81, and the square root of 81, you might just look at it and go, I don't know. Honestly, the best way you can work out is just start from, say, 5 or something. Okay, 5 times 5, 25. Too small. Go to 6. 6 times 6, 36. Still too small. And just work up until you get to a number that it will work with.
Yeah.
But it's just
cool.
understanding the squares and square roots. To be honest, it was only after I've actually put this course together that I've seen this pop up. So it's actually a really, really good question. So
yeah, because I was answering them questions, timesing it by 2, and then realised that obviously square is something completely different. It's just it's so easy to forget, isn't it? Especially when you haven't done it for a long time.
yeah, it's a really common one, the squaring thing as well, because you see the little 2 there and you just think it's a 2, times it by 2. But
yeah,
it just takes a little bit of time for it. So so moving on to our next
all back to basic, you know, the table. 1 by 1, 2 by 2.
Yeah. You can have it with the
maths is all about basic in the end, and if you can remember by memory, because some are quite easy, but you know, it's a you don't need to writing down.
It is quite easy to remember. That's actually a really good point, Simonetta. It's the idea of, like, with the square numbers as well, you can link it in with area. They're called square numbers because they are the numbers that make up a square if they're arranged. So 4 is a square number because you have 4 squares together, it makes a 2 by 2 square. So because it's 2 times 2, your square then has 4 in it. If it's 3 long and 3 high, then your square will contain 9. And then that's the whole idea with the square numbers, really. That's how they work and how they get a bit bigger there. So so moving on then. So looking at the compound shape then. So compound shapes are basically 2 shapes that are put together. These will pop up quite frequently. They look more confusing than they are. They're really not that bad. So the idea is it's just a shape that's been made up of lots of different shapes. The key idea is that we just take these more complex shapes and we split them into simple shapes, find the areas of both of them, and then just add them together. So an example then, so if we were asked to find the area of this shape here, immediately it looks a bit more daunting than it is. The best I can do is always fill in the gaps. So if I know that this length here is 8 and this length here is 3, then I know that this length here is going to have to be the difference there. So that's going to be 5. So that's got to be 5 because the total length is 8. And you can do the same here as well. If this part here is 8 and the full length is 12, this part here has to be 4. So that always seems to help me out a little bit, just kind of dividing it. You can divide this. Yeah, it's normally to do with floor plans and things like that, or people putting down carpet. It's always the same, like. But so with this idea, then you can split it in numerous different ways. So I think the example here splits it. Yep, so it's just going to split it with a line down here. So then all you're going to do from here then, if we work out the area of this little section here, so the area here is going to be 8 times 5, which is our 40. And the area here is going to be 8 times 4, which is going to be 32. And again, the 4 has come from this length here. So we know it's 4 long and 8 high. And we know this one here is 5 high and it's 8 long. Obviously 12 is the length of the complete total there. So it's just picking your numbers carefully as well. And then we're just going to add them together. We could have, if we wanted to, we could have split it across here as well instead. And then we could have done 12 times 5 to get the whole top area. And then 3 times 4 to get the bottom area. It's whatever is more comfortable for you in regards to dividing it and splitting it. But that's the idea with the compound shapes. That's all they are. It is just two shapes that are put together, and then you just need to work out the area. They do like to make them a bit more complicated sometimes. So you might get, like I was saying earlier, you might get like a rectangle with a semicircle on the end. So in that case, you work out the area of the rectangle, the area of the circle, and then you half the circle and add them together. Or it might be like a square with a triangle attached to it, something to that effect. So long as we know that we can just split it into the simpler parts and work out the individual shapes, we're absolutely fine. So another quick example then. So I'll leave this one up. I'll let you guys have a quick go at this one. And then, although there are quite a few questions on compound shapes, I'll probably get moving on to the volume and surface area, because that's where people seem to kind of need a little bit more working on it. So have a bit of a look at this one then. See what shapes you can split it into, and try and remember all of our formulas. So obviously dealing with a triangle, half a square. Okay, lovely. So we've got some answers coming in then. And do remember, it is the case with these where it will be, so looking at all the units there, so it's going to be in meters in total. And it will be meters squared as well. I know it's difficult to type it in, so I've got a fair few of the same answers, one or two slightly different ones. But again, I don't actually know what this one is yet, because I haven't worked it out yet. So I think if it's okay with everyone, we will just start having a look through and we'll see what we get for this one then. So I'm hoping most of us have thought about it and we thought, okay, let's split this shape up then. It's a triangle and it's a rectangle. So here are our two equations then. So we know on the bottom there that it's going to simply be 6 times 9 or 9 times 6, the same thing. And that will give us our 54. And then we know on the top, it's going to be, it's obviously our base is 9 meters long and it's 3 high. So it's going to be 9 times 3, which would be 27. And then we've divided that by 2, which has given us 13.5. So we can see here, even though this looks a bit more complicated, we know that a fraction is a sum. Some people just prefer to write like this. I'd rather write like that than actually write divided. So we should have got an answer then in total of 67.5. So if you've got that, well played. If you haven't, then I'm hoping that that will show you kind of where we might have made a bit of a miscalculation or where we might have gone wrong a little bit. You
write centimeters as well. It's no meter.
Ah, yes. Well, mate, you're pulling me up on everything today, aren't you?
Well, because you just said and I corrected, and now I see centimeters and up is meter.
I saw it. Yeah, I saw your message come through. Oh, sorry, I meant meters, and then I've done it wrong. So fair enough. Yeah, that's spot on. I'll change that one then, or I'll just change the question so it's centimeters instead.
You have to correct your PowerPoint.
Yeah, I know it's a bit old and battered. Karina, that's brilliant. Then, and again, the best thing with this is, although it's a little bit frustrating sometimes, like if you get a question wrong and you think like, oh, I'm not doing very well with it. The great thing is, at least if you're picking up on why it's gone wrong at the beginning, you'll actually spend more time, you'll make more of a semantic link with that, and it'll actually embed in your memory more. So by actually making a mistake and correcting it, you're actually going to probably have a deeper level of understanding of that content. So brilliant. So that's that one there then. So that is compound shapes. I don't think we're going to look at these because I think there's another little bit of a quiz, which is a little bit quicker to do. But if you want to come back and look at these in your own time, absolutely brilliant. So again, there's obviously a 2 rectangular shape, and we've got one with a semicircle there. So we'll look at 1 or 2 of these, and then we'll get moving on to volume and surface area, because I think that is a bit more important. So we'll look at this one, and then we'll look at one more. So again, so we're looking at the area of this shape, and these are our options. So I'm hoping you can spot straight away that some of the units aren't quite right. With the last shape as well, and even with this one as well, if you do get a little bit lost with, you know, working out or remembering how to work out the idea for the triangle, again, just it's practice makes permanent. It's that idea of, okay, I need to remember the formula for triangles a bit more. Some people prefer to remember it as height times base divided by 2, and they remember it that way. I always remember it as just half of a square. Again, I'd better work this one out as well because I have no idea. So what does help sometimes as well, I know I'm a common person for saying the you know, if it's tricky, draw a picky, but it does help. You can literally, if you want to, pull this shape apart and you could just draw it separately. Again, you're not going to lose any marks for sketching things separately. So this is essentially a square and triangle, and then by then making the notes here and here, you might be able to just see a bit clearer what all the measurements are on that triangle and on that square.
No, I cannot know how to do this well. I'm just lost.
Oh, that's okay, no worries.
I've got a completely different answer to what's on the screen.
Exactly. I me too. I have no answer exactly like this. My one is 18.
What did you get, just out of curiosity?
I got 18.
No, I got something completely different to that.
Tell me now. Tell me mine. Tell me yours.
Well, I got 220 centimeters squared.
Oh.
Which is like huge.
Yeah, one thing that might help is if you look there.
Yeah, well, I converted it to millimeters, all of it to millimeters.
Ah, okay.
You might want to centimeters. So.
Oh, I don't know what I'm doing now.
No, you're absolutely fine. So the thing is, you've noticed it and you've converted, which is absolutely brilliant.
I did notice it, which is the first.
And then you've just converted it. So it will normally say, give your answer in centimeters squared or in meters squared. So because all of these answers are in centimeters squared, it would then be an idea of converting the whole thing to centimeters squared. So did you say you ended up with 240?
220 centimeters I got.
Okay. So if you'd have converted these to centimeters, then so I'll quickly talk through this one and then hopefully it'll kind of help out a little bit. So it should be, so most people are arriving at the right answer now. Yeah, so if I convert this first of all, so this is just going to be 4 centimeters here. So then we've got the area of our first little box here then is going to be 4 times 4, which is going to be 16. So I hope we're all quite happy with that. So the area of our box there is going to be 16 centimeters squared. And then the area of our triangle is going to be obviously, so we need the base length here, which is going to be 4, because the whole thing is 8 and this part is 4. So that's going to be 4. And we're going to multiply that by 4. So 4 times 4 again will give us 16. But technically that 16 would be the area of this whole rectangle, which we don't need. So we're going to half that, and that's going to give us our 8 centimeters squared for our triangle. And then we just add both of them together and we've got a total of 24 there. So hopefully that's cleared things up for people. So the answer that you should have been looking for, is 24 centimeters squared. Steve, I'm sorry that Zoom doesn't seem to like you today. It's not me. It's just, I've had it a couple of times in all fairness where the meeting just randomly just boots people out for some reason. So sorry about that, buddy. Okay, so because we need to get on and we do need to look at volume and surface area, I'm going to kind of nip through these, but I'm hoping it's okay for you guys that you know that these practice questions are there for you. So if we move through then, oh, there was only one on there. Brilliant. Okay, so how to calculate the volume of a cuboid. So a bit of fancy terminology, but a cuboid is a prism. And basically what prism means is that wherever you cut through it, it looks the same all the way through. So if you imagine like a Smarties tube, that's like a hexagonal prism all the way down. If you cut it in half at any point, you would have the same shape. So to find the area, you simply find the area of the cross section and then multiply. So it seems a bit fancy worded there, but hopefully this will make sense. So the idea of volume, it's just the height by the width by the length. You just times all three together because it is the same in all three directions. So you can write it like this. So volume is height times width times length. Okay, but this is generally how we're going to calculate the volume of all prisms. So it's finding the surface area. Essentially, we just find the area and then we find out how deep it is. So hopefully, if we're looking at these here, then, so this here is a rectangular prism, a triangular prism, and then we've got what would be a cylinder here or a circular prism. So it's the idea of, we'll just get all we need to do to work out this volume. We just work out the area of the square, and then we find out how deep it is. So as a quick sketch for you, it's the idea of if I had, let's say, this square here, so I've got a 2 by 2 square. I think we'd all be quite happy at this point because this is 2 here and this is 2 here. In total, that is going to be 4 centimeters squared. There are 4 square centimeters there. If I then extend this and I now make it a 3D shape, we're going to be dealing with volume in this case. And again, if it's 2 squares deep, I'm hoping we can all kind of see there. So to calculate this, we're looking at how many cubes there are now. I'm hoping everyone's okay with that. We're going to have 4 on the first face here, and then we're going to have 4 back here as well. And one of them is going to be obviously down there, kind of hidden. So to calculate that, it's just going to be 2 times 2 times 2. Or it's the area of this face here. So it's our area here multiplied by how deep the shape is. So again, if it was for a triangular prism, it would just be working out the area of the triangle and then multiplying by how deep that triangle goes. Quite a nice, straightforward kind of idea. And again, the same even for a cuboid, although not a cuboid, sorry, a cylinder. Even if it looks a bit more complicated, we can just work out the area of one face and multiply it through by how deep it is. So you can remember it in either way. It can either be the area of the cross section, or again, just the main face multiplied by the depth, or you can just remember it as the height times the base times the depth. Either way, it's the exact same thing. So as a quick example then, so if we're looking at finding the volume of this cuboid, it's a simple case of we can just work out the area of the face and then how deep it is. So in this case, it's going to be 3 times 5 times 4. So 3 times 5 will give us the area of this, and timesing it by 4 will tell us how deep that is. So the volume here is going to be 60 centimeters cubed. And again, it's going to be cubed because we got centimeters times centimeters times centimeters. So that's one example. There is also an example. You can do this by working backwards if you wanted to. So it's the idea here of if it's giving you a volume and it's asking us to work out the height, although it looks quite complicated, because we know that the volume is equal to the height times the length times the width, we can just kind of simply use this. If we do obviously our volume and then we divide it by these two numbers, we will be left with this part here. This type of the question doesn't really pop up very often. I just thought I'd throw it in there as a bit of an idea. So we know that it's 10 times 7 times something is 280. So we can rearrange it then. So 280 divided by 70, or 10 times 7. So it means that the height of this one will be 4. So what I'll quickly do before we start looking at this triangular prism, I will just quickly give you guys an example to work through just for you guys as well. So if I draw this shape quickly, oh no, that's a line, I don't want that. Okay. So if I very quickly draw this here, okay, and it's going to be 5 high, 10 long, and 10 deep. And we'll just say that all of these are in meters. So what is the volume of this shape going to be? So this shape here, we're ignoring this one for the minute. We'll look at that in a second and have a quick look through it. But just put very quickly and say, what is the volume of this going to be? Karina, absolutely spot on straight away. Nice one. So do remember this, we are multiplying all of these numbers together. The reason being, and we could sketch it on there if we wanted, this is obviously 10 long and 5 high. So there would be 10 on this row here. So that would be 10, 20, 30, 40, and 50. So there'd be 50 squares just on that face. And it's 10 deep. So it's going to be 50 times 5 again. So it would actually be 500 cubes in there, or 500 meters cubed. So I hope that's okay with everyone then. So what I'm going to quickly do then is just talk through this example again, and then I think there's one more example of another prism. And then there's a couple of questions that we can look at and kind of try and work out. But the main thing is with these, although they look quite complicated, it's just a case of multiplying all the numbers together, really. So with the triangular prism, we want to work out the area of the face first of all. So, you know, we know that if we work out the area of this face and multiply it by the depth, then we will get the overall area or the overall volume. So, important thing to note as well, it's always the vertical height of the triangle that we're taking, not the height of the slant. So this 8 there isn't actually important at all. So we just need our 9 times 11, which is going to give us, oh, sorry, the vertical height there is 8. So the 8's important, the 9's not. I do apologize. So it's the 8, which is the vertical height. So 8 times 11, and that will give us 88. And that would be the area of like a square face, if you can imagine it here. And then by dividing that by 2, we've then got 44 centimeters squared. And that is going to be the area of this whole face here. So we've worked out the area of this face here, which is absolutely brilliant. And then all we need to do is we now know that it is 20 centimeters in depth as well. So we're going to take that number, we're going to multiply it by 20. So we've got our, and that's going to give us our volume. So we've got our area of the cross section, multiply it by 20, and we'll end up with our volume there of 880 centimeters cubed. So although it looks a little bit more confusing, it's the same thing. It's just, I'm hoping you can see how all this kind of stacks and builds on each other. So, you know, obviously building from 8 centimeters, you know, working out the area of the triangle, and then from knowing that, we can then work out the area of a triangular prism. Same with area of a square, we can then work out the area of a cube, etc.
So do you still divide that by 2 then, because it's a triangle, or is that not?
Yeah, we still do. And that's where this part here. So that's why we divided it by 2 there.
Oh, okay.
So you could really, if you wanted, I'm not sure actually, I'll quickly check it. 11, 8, 24. You know what, even if at the very end you divide it by 2, you get the same answer. So that's actually a really good point. So what you could do is if you were to do 8 times 11, you're actually working out the area of a square like this.
Yeah.
And then if you multiplied that by 20, you're working out the overall volume of that cuboid. And then sorry, that looks terrible, doesn't it?
Better than what mine would look like.
That's better. So yeah, so even if you worked out that, then you work out the overall volume. If you then half the volume, the same principle applies, and it will actually work out. So this kind of section on this side here, so this kind of little triangle down here, you can imagine it, and the triangle here, it will actually get rid of them, and it will give you half the volume, which will be 880 again.
Okay.
So
perfect.
Sorry, but I wouldn't do like that, because if I look you with my eyes, it's not really a regular 3D things, because if it's one side 11 and the other side, what, 2 sides is 11 and one side is 9, and you give me the one perpendicular 8 centimeters, I will do first one side and after I will do the other side.
the idea with this
And
one,
maybe I'm wrong, or I say in a wrong way, I don't know.
it is basically what they've done here is similar to like some of the area questions where, so it is still a prism because it is mirrored on both sides. They just haven't put all the information in. So we would know like this line down here, for instance, that would be 20. This line here would be 11. And this line here obviously
9.
would be 9, and that would mean this line back here would be 9 as well. And the line along the bottom would therefore be 11 as well. But yeah, it's they do that sometimes, and it looks a bit more confusing because you look at it and you go, well, if that's 11 and that's 9, then it's not going to be the same. The good thing I was taking from it is it doesn't matter if the triangle is a bit strange. So with this triangle, it's not a nice right angled triangle, and it's not an equilateral triangle.
Yeah.
It would be a scalene. It'd look kind of a bit more wiggly like that.
Yeah, exactly. Which is why I would do first one side of the area and the other side, and after, I don't know, maybe I'm wrong, or I do the things more complicated when they are.
So with this, it's still the idea of just looking at the idea is, where'd my annotating thing go? So with this, so with the area of the triangle, it doesn't matter if the triangle's a bit strange. So if I draw a really weird triangle, so let's say like that, if I know that this base length here, it's still a concept of, we'll still make this into, sorry, it's got to be flat on the bottom or I just can't draw it properly. So say if it's a triangle like that then, so we've got obviously 3 different lengths. When we work that out, we're still going to work out the area of this rectangle. And then when we divide it by 2, it doesn't have to be equal. It's easier to see in a very nice kind of right angle triangle like this. You can easily see that we've got half here. So that's half and that's half. Whereas here, it's like this is part of the half and this is part of the half, but they will always total the same thing. So both of the shaded areas there will still be the same as this one here.
Yeah, I know, because the square divided 2. Simple like that. But
yeah, it's just with some of it, it just does look a bit strange.
Yeah, so it looks a bit strange. I hope it doesn't come out something like that. But...
No, you wouldn't. They'll only ask you to find the volume of a prism, so it will always be a shape with the same front and the same back. So yeah, no crazy complex shapes that are getting bigger and smaller. So in regards to a formula for this, then. It's the same idea here. So it's the idea of the area of the cross section times the depth. You could expand that a little bit, so you could have the area of a triangle times the depth. So for this, it'd simply be, I mean, if we wanted to make it look very fancy, we'd have height multiplied by base. So that would be like the area of our rectangle. we divide that by 2. We do that first, obviously, so I'm going to put that in brackets. And then we just multiply that by the depth, or how deep it is. So although that looks very fancy and mathematical, it's just saying the area of a triangle and then multiplied by how deep it is. So that's the idea there for that one. And those are really the only 2 you need to know. We will have to, you might have to maybe work out the area of a cylinder as well. It'll be the same thing. It's working out the area of, or the surface area on the circle, and then how deep it is.
Yeah, I remember on the exam, I had a cylinder when someone put the post to send it by post to, which, my God, I couldn't do it really. Yes, it was like a nightmare. I just keep, and no.
It's like with it. So again, now that we've hopefully looked at it a little bit, so we'll look at this one a little bit, and then I do need to cover the surface area stuff. So with this then, although this looks horrible and people are probably already going, oh, I don't know what I'm doing, it's the same concept. We know how to work out the area of the circle. So we know our 2 formulas for our circle. We've got diameter times pi, and then we've got 2, oh no, we haven't, I'm lying. Written that one wrong. Come here, you. Yeah, and then we've got pi radius squared. So out of these 2, again, I'm hoping everyone's okay. We know that this is the one that we're going to use because this is calculating the area, because our units there are squared. So all we have to do, so we've got our radius of our circle here. So if we put these numbers in, we've got radius squared times pi, and that will give us the area of that top circle. So again, it's still the same thing. It's the area of the cross section times the depth. So in this case, we know that the area of the cross section is pi times the radius squared. So that's going to be 3.14 times 6 times 6. And that's going to give us our unit here. So we know it's 113.1 meters squared. So again, when it starts going to decimals, people tend to get a little bit worried as well, but we don't need to, because we still know what we're doing, even if the numbers look a bit horrible. So that's told us the surface area here. So that's the whole area of this top bit. And we know that that circle just goes down for 15 meters. So therefore, all we have to do at this point is take that number and multiply it by 15. And that's going to give us our overall volume. So again, with these cylinders, although it does look a little bit confusing and stuff at first, so long as we're aware and we're confident in how to work out the volume, we should be quite happy with it. So, and it's making sure that we use the right formula as well. So we know we've got our 2 circle formulas, and it's just remembering this one here, pi r squared is for area, diameter times pi is going to be for the circumference, so around the outside of it. So again, I'm hoping that's okay for everyone.
Well, I have to say, you make very easy and very understandable, especially for the cylinder and the radius, diameters, and all this.
Oh, awesome! I'm glad to hear it. Again, I'm hoping I'm doing a better job of when I got taught it in school, because again, they just threw a textbook at us and it was just a load of nonsense. Really, I had no idea why you get the formula, but you don't know why you've been given it. So, we've got some questions here, but I am just a bit worried about time. So what I'm going to do is I am going to skip over these, but they are there for you guys to obviously practice with. So when you do look back at it, then that's obviously how we can work them out. So there's a couple of extra practice questions there for you. So the last thing we need to look at then is surface area. So this is the area of all of the faces of a 3D shape added together. And this is where, again, knowing what all the numbers are comes in very, very useful. And again, this is a bit more linked to the issue that you were saying about a minute ago, Simonetta, with the idea of like the different faces and knowing that sometimes you have to find all of them. So you could think of this like, it's the exact amount of wrapping paper you need to wrap yourself a shape. So it's just working out how we would wrap something up. And it's again, remembering if you are wrapping someone a present, you wrap the bottom, the top, the sides, and the front and the back. You don't just not wrap the top up. And there's just an example of kind of, I don't know, a really badly wrapped present for some reason, more like how I would wrap stuff. So anyway, moving on. So that's the idea of surface area then. So if we wanted to find the surface area of this cuboid, and again, it's always worth kind of really kind of like looking at these questions. And I'm liking that I'm saying this. I don't know if you can hear that my partner's actually wrapping stuff in the background as I'm talking about wrapping stuff in maps as well. So it's quite good. So the surface area then of this, it's going to be obviously working out all the different faces of this shape. So, and again, a lot of people do tend to forget about the bottom and the top. They do have questions where they'll ask you things like, you know, making the surface area, and then, yeah, so making the surface area, and then they might say that the top isn't involved in the problem, or maybe the sides won't be involved. So it's just reading the question carefully. So with this then, so first of all, if we work out this face here then, so I'm hoping we can all look at this and we can say, well, that's going to be 4 centimeters by 10 centimeters. So this is going to be like 4 centimeters times 10 centimeters. So that's going to give us our first area there of 40 centimeters squared. I'm hoping you can see from the next part underneath it there, we've multiplied it by 2. The reason being, because that's going to be the front and the back. It's entirely up to you how you want to do it. You can just work them all out individually. But so we've got the front and the back now, and that is 80 centimeters squared in total. What we've then got is this kind of this side. So we know that's going to be both the sides there. And again, it's difficult sometimes to pick out what numbers you're going to need, but I'm hoping we can look at this and say, well, it's 5 along and it's 4 high. So in this case, that's going to be 5 multiplied by 4, which is going to be 20. And it's going to be 2 of them because it's the side and the other side. So in total, that's going to be 40 centimeters squared. So now the only 2 that we're missing is going to be our top and our bottom. So looking at this, I hope we're okay. We know it's going to be 10 centimeters along, but it's going to be 5 centimeters deep. So in this case, we're going to have 5 times 10 equals 50. And we're going to double that for the top and the bottom. So we've got a total of 100 there. And then all we need to do is add all of them together. And we're going to end up with a surface area of 220 centimeters squared. So normally, when we're looking at the functional problems, it is worth noting what they are asking us. And I'd recommend doing that right at the beginning straight away. So if you see a shape pop up, just, you know, look at it and go, are they asking me for a perimeter? Are they asking for an area? Are they asking for a volume? Or are they asking for a surface area? And then you can look at the units and they'll normally help. So I'm just going to have a quick look at if we've got any other questions on these very quickly. So there's a surface. I'm just going to have a quick glance through. Okay, so what we'll do then, I think we'll have a look at these. Hopefully no one looked at the answers there. So we'll look at these then. Actually, no, you know what? I'm going to leave these ones for the minute because the surface area on them it doesn't really explain exactly how to do it as much. And what I've done here is I've actually converted the units as well. So this would be a very high marked question if we were to look through it. Actually, no, you know what? Sorry, I'm getting lost in my own head. We will have a go at these ones. So we'll have a go at cuboid 1 here. We'll all have a go at this one, and then we'll have a look at the next section afterwards as well, because I just wanted to show how it works with the triangles and the cylinders as well. So if you have a look at cuboid 1 then, and try and remember, so we are looking for the surface area of this shape. So we need to know all 6 of the surfaces, and we need to work out the areas of all of them. So I'm hoping everyone's quite happy at looking straight away and noticing that we need to shift these units as well. If you have to adapt the units, it's a really good idea to always do it right at the beginning. If not, it can cause problems. If you think about it, if we're obviously that 90 there, if we were to do 90 multiplied by 5 multiplied by the 6, say if we were calculating the volume, for instance, this could actually produce more of a problem in the long run, because our answer is not going to be just 10 times off. So from millimeters to centimeters, it's then 10 by 10 times off. So our answer is going to be 100 times wrong. But anyway, so have a go then, see what we end up with. So we're looking for the surface area. So we need to know the surface here, here, and here, and then essentially double them. So Karina, absolutely spot on. Well played. That's brilliant. Really quick as well. It normally takes me a bit longer to work these out. So
calculator. I can do everything with a calculator.
yeah, it's difficult sometimes though, because again, like the nice thing is if you use the brackets on the calculator as well, you can just put it all in straight away. So you can do, say, if you work out the base there, you could do 5 times 6 times 2, put that in brackets, and then add the next part, and then add the next part. Becky, yeah, spot on. So again, I'm hoping everyone's a bit more comfortable with this. So the actual maths behind it is not very complicated at all. It is just a simple case of multiplying numbers. It's just understanding what numbers to multiply, which causes a little bit of confusion sometimes. Cool, yeah, Simonetta, spot on as well, brilliant. And again, really, really good use of the units as well. So it would be centimeters squared in this case. I mean, it doesn't ask specifically, so you could have converted to millimeters and worked out that way. But obviously centimeters is going to be a smaller, more reasonable answer. So yeah, it will be centimeters squared though. It won't be cubed because we're not working out the inside. We're not working out the volume. We're just working out obviously all the wrapping paper all the way around it. I feel like a bit of a mime artist there. It's quite good. Okay, so if I just write this down very quickly then, so I'm hoping everyone's done the conversion initially. So what we should have is essentially 3 different sums. So we should have our 9 times 5 times 2. So that will be for this first face here. So 9 times 5 will give us the area, and we've got 2 of them. And then we're going to add to that, we're going to add the top of the shape and the bottom. So that'll be 5 times 6 times 2. And then at the end of that, we're going to add the sides on there as well, which will be 9 times 6 times 2. So that's for both of the sides as well. And again, although this looks very fancy because it's got brackets in it, you could just type all of that straight into your calculator and get the answer in one go. But I would recommend working out each one and writing it down so that then you can get the marks for workings as well. You should come up with 258 centimeters squared for that answer there. So hopefully if you have gone a little bit astray, then you know why or where you have. Again, some people do really struggle with the idea of like kind of visualizing these things in 3 dimensions. It can be difficult sometimes.
Is it squared or cubed? I'm confused now.
So with this, it will be squared.
Oh, I was right then.
Yeah. So the reason being, it's just, obviously cubed is when we're looking at the inside of the area, so it's the volume.
Yeah.
So it would be the front face multiplied by how deep it is. Whereas with the surface area, it's going to be a case of, obviously, it's just the area of the entire surface. So
yeah. No, it's just because you said about the cubes, and I thought you was referring to me. I thought it's my answer that I put it wrong.
Oh, right, okay. No, just generally explaining. So, so again, so I'm trying to think of another way of kind of explaining this. I think if you were to try and kind of put this as like a formula, so to say, you could just kind of simply write it as, if I can find the pen, where's the pen gone? How do you lose a pen when you haven't actually got a physical pen? So it is just the area of the front and back plus the area, or plus the area of the top and bottom plus area of both the sides. And again, you could break that down even further if you really wanted to. And you could say, obviously, you know, height times base, add height times length, add height times width times 2. But again, I think that would just be looking a little bit too complicated. So it's just the idea with this one, you know, just knowing what we're working towards is the main way of remembering it. So it's just going to be work out this first one, adding the front and the back, adding the sides, adding the top and bottom. So hopefully that might just be another way that might help some people kind of understand it a bit more as well. So add the front and the area of the front and the back, the top and the bottom, and the 2 sides. So moving on then. So if we look at the surface area, say here. So again, and this is where obviously Simonetta kind of come up with this idea earlier. It's the idea of we're getting different measurements and things out. It's quite difficult sometimes to spot how many faces there are and how to work it out. But if we all have a quick go at working out the surface area here then. So just remember, we just need to work out all the different parts. So we know we've got these 2 triangular faces on the ends. So we're going to have 2 of them. So we've got 2 triangle faces. So we're going to need the area of them. And we've got a base on there. Then we've also got our main slope and then our second slope. So all of these are going to be a little bit different. So the base is going to be different from here and different from here because the triangle itself is not symmetrical. If it was, you know, in a perfect way, if it looked like a Toblerone, you know what I mean, it was just, you know, nice, the same on each side and the same on the bottom, then we could just work out the base and multiply it by 3 and it'd be an equilateral triangle prism and it'd be great. In this case, so we're going to have to work out obviously the base, the side, and I guess what we'll call the front as well in this case. So again, with this, it is just a case of just picking out the numbers or like the areas, like the right numbers for completing this. In regards to a formula for this, it is just calculating the area of all the faces. There's not really any way of writing it any simpler. It is just, you need to work out the area of everything. Might be worth maybe counting the faces at the beginning as well is always a good thing. So we know there are 2 triangular faces that are mirrored, and then we've got 3 other faces. We've got the base, the side, and what we're going to call the front or the other side. The nice thing with these types of questions as well is they're normally included with a lot of other working. So, and again, we will see this when we look at some of the actual exam style questions as well. There was one recently on the non-calculator paper. It was a question very similar to this, and it came up and it was a 6-mark question. The great thing about it was one of the marks was for a conversion of units at the beginning. One of the marks was for multiplying, because it was a man who's trying to work out the surface area of 3 identical shapes. So one of them was for working out, you know, whatever surface area you get times 3, and one was then multiplying it or dividing it by 10 for the amount of liters of paint. So 3 out of the 6 marks weren't actually for calculating the overall surface area, which was quite amazing, really. Okay, cool. So we've got an answer that's come in then. I'll give you guys another minute or so on this one. We'll probably make this one the last question. So do remember this one, because we are dealing with a surface area as well. It is an area, so it will be meters squared will be the units. So I think everyone's got an answer coming in. So what we'll do is we'll start going through it then, and we'll see how we've done then. So if we that's going to be very annoying. Hang on, what's going on here? Clear that. Leave that. Okay, so first of all, so we work out the area of the triangle then. So that's the triangle on the end. So we know it's going to be 3 times 6, and then we're going to divide that by 2. So it's the same as writing a half times 3 times 6. You get the same answer. So 3 times 6 is going to be 18, divided by 2 is going to be 9 meters squared. And we know we've got 2 of them. So that is the front and the back, so to say. So that's going to give us a total of 18 meters squared, which is absolutely brilliant. So we've got our 18 meters squared there. And again, you can work these out in any kind of ways that you want to. We've got a rectangle on one side, so rectangle 1, let's say. And they've put this down as 10 times 6. So that is going to be the area here of this bottom kind of piece here. So the area of the bottom then, 10 times 6, is going to be 60 meters squared. We've got our second rectangle, which is going to be 7 times 10. So that's going to be this slope going upwards here. And that's going to come in at 70 meters squared. And then we've just got our back panel then, which is going to be obviously 10 long and 3 high, and that's going to be the back there, which will give us 30 meters squared. So in total, we are looking at 178 meters squared. So I'm not sure how did anyone get that one? Yep, Simonetta, well played. Got some answers that are close to it as well. So again, with these types of questions, really don't worry too much about it. If this were to pop up in an exam, and they do pop up, you know, every now and then, they're not guaranteed to pop up, this type of question. But if it does, and you make a miscalculation, so long as you know how to do it, even if you make a miscalculation there, you can still get normally, you know, 5 out of the 6 marks. If you'd have gone through and calculated the area of different things, but unfortunately you've used the wrong number, you would only drop 1 mark. It's your knowledge of showing that you understand surface area that will get you the extra mark. So yeah, there you go. Someone's already mentioned that. It's just multiplying the wrong numbers. You'd only drop the 1 mark for it. You wouldn't be able to get the overall correct answer, but you still prove that you know how to work out what the surface area is. So again, these are a few more for you guys to practice on. Again, I haven't really got the time to go through them all now. Again, it's quite tiring as well working with surface areas. It's a lot of just maths on maths on maths. It kind of drains you a little bit. There are a few more examples in there for you. I just thought I'd put up one example of a cylinder as well, which I'm just going to talk through this one quite quickly. So this hasn't popped up in all fairness. The surface area of a cylinder, I've never seen it appear. But just as an idea, if we wanted to know what it was, it would be a case of we'd need to work out the area of the top and the area of the bottom. So obviously that's our wrapping paper. And the strange thing is with this here, with the bit around the center, if you imagine, if you were like, almost like looking at like a tin of chocolates kind of thing, if you were to peel the label off, you actually end up with a rectangle. So when we're working out this, so it's essentially working this out, it's two circles and a rectangle. And the length of that rectangle is going to be the circumference. So if this is starting to go over your head a little bit, please don't worry too much about it because this hasn't popped up before. But it's just saying, if I took that circumference, I took the circle. So imagine we're looking from our plan view. So from the top, we're looking down on, let's say, like a tin of chocolates, and we're going to peel the wrapper off. If you start to actually open that up, it's going to be the circumference of a circle that opens all the way out and ends up as the length of this rectangle. So what we'd do here then is we'd work out the area of the two circles. So we know that our circle here is going to be pi r squared, and therefore that will be the same on the top as on the bottom. So we'll multiply that by 2. And the rectangle itself is going to be 5 times 8, so that's pi times diameter, and that will give us the circumference. And we're going to multiply that by 5 for the height there. So that is like the most complex question that there will be. But again, if that's going to be head, please don't worry, because I've never seen that pop up in regards to asking for the surface area of a cylinder. So there are some examples there for you if you want to use them. So the main thing from today then that we've looked at, so we've looked at what area is, what perimeter is, volume, and what surface area is. And hopefully we're all quite clear on them now. Hopefully we've all got ways of calculating the area and perimeter of simple shapes. So we know that any rectangles, it's going to be height times base. And if it's a triangle, it's the height times the base divided by 2. We've looked at our area and circumferences of circles. So again, we know that the circumference of a circle, or the perimeter, is going to be pi times diameter, nice and straightforward. And we know that the area is going to be pi r squared, and that's just something that we're going to have to just try and remember, really. We've then done some work with compound shapes. So we're going to actually, yeah, Karina, no worries. So we're going to, obviously, we've looked at compound shapes, and this is the idea of two shapes that are stuck together. And again, there's a lot of practice for this on the Google Classroom, but it's just a case of breaking the shapes into simpler shapes. Why is that not working now? And then we've looked at ideas of calculating volume and calculating our surface area. So all in all then, we've covered quite a lot today, and I'm hoping it's that idea of, you know, really looking at the units and making sure our units are the same, and knowing when to use the units is going to be really, really important there. So the last thing that I'll do very quickly is, if I go on here and over here, so hopefully you can all see my screen again. So it was just to let you know that if you have a look through the Google Classroom, look in here, so in percentages, I've added a few extra bits here. So you've got the reverse percentage problems and compound interest problems now as well. So I've just broken it up a little bit more for you. Those are the resources from last week, but you now also have all of these resources here on these topics. So in each one, obviously we do have lots of different worksheets with all of the answers attached to them for you. And again, these go all the way through compound shapes, volume. There's a lot of work on circles in there, and there's a lot of different resources. So hopefully that should be fine for you. And I will upload this video or this recording as well. So that I'll put that in the topic overview, and I'll put that on there later on today, so everyone knows what's going on. And that is it from me. The only thing I do need to mention as well is next week we're going to be looking at compound shape and compound measures. It's a topic that we have to cover, but I've never seen it appear on a level 1 paper, and I've looked through the scheme of work and the spec, and I don't think it's actually on there. So it's a topic that is only really needed for people that are doing the level 2. I'd recommend it for if you are doing the level 1 assessment, then do come along anyway, because I'm assuming with most people we're aiming for the level 2 in the long run, so it would be beneficial for you. But if you are on the level 1 and you fancy just going, no, maths, no, then I can send you some, I'll upload a different assessment onto the Google Classroom and let you know what it is. So if you don't want to attend the next session and because you're doing the level 1, then don't feel that you have to, but I'll let you know what additional assessment we can do instead. And then, yeah, hopefully by next week, guys, if you can try and get the assessment on area and perimeter finished for me, and try and get any other ones that you haven't done yet, that'd be spot on. And that's it from me. So I hope that was all right for you.